Hey guys, so today we're back with another video about the JEE Advanced questions from the Vernier Calipers, and this question that we have right here is from the 2016 paper. So let's read the question. There are two Vernier calipers, both of which have 1 centimeter divided into 10 equal divisions on the main scale. The vernier scale of one of the calipers, C1, has 10 equal divisions that correspond to 9 main scale divisions. The vernier scale of the other caliper, C2, has 10 equal divisions that correspond to 11 main scale divisions. The readings of the two calipers are shown in the figure. The measured values in centimeters by the calipers C1 and C2 respectively are. So basically here they gave us two scales, C1 and C2, showing some different readings, and they gave us two different conditions, the one which is underlined in red and the other one which is underlined in green for C1 and C2 respectively, and we're supposed to find the reading of the measured value in C1 and C2. So it seems like a pretty straightforward question because there isn't really much to do here, especially since all of these are in, okay, wait. So let's see. Especially since C1 is in our regular form and C2 also doesn't seem to be much. So let's see. We'll first decipher C1. So, they told us that C1 has, also they told us that 1 centimeter is divided into 10 equal divisions on the main scale. That's our usual thing, that 1 centimeter has 10 divisions, so each MSD is 1 millimeter. Those are our usual conditions, so I'm just going to write that somewhere here. 1 MSD is equal to 1 millimeter. And in C1, they said that 10 equal divisions that correspond to 9 main scale divisions. So that means 10 vernier scale divisions is equal to 9 main scale divisions. And then this is our usual case, so we'll get the least count as 0.01 centimeters. And from this, we can easily read C1. So let's see, what is the main scale division? Or actually, let's first find the vernier 0. Vernier 0 is right here. And the main scale division, that is to the left of the vernier 0, is this, right here. So which main scale division is that? That is 2.8 centimeters. So our main scale reading here is 2.8 centimeters. Now we have to find our vernier scale reading, which is the vernier coincidence times the least count. So that's what we have to find, the vernier coincidence. So let's see, none of these are coinciding so far, but this one is coinciding. So which one is this? This is 5, 6, 7. The 7th vernier scale, vernier scale division is coinciding, and hence we can say the vernier scale reading is equal to 7 times 0.01 centimeters, which is equal to 0.07 centimeters. So we've got the MSR and the VSR, and our final reading R is the sum of both. So our reading R is equal to 2.8 plus 0.07, which is equal to 2.87 centimeters, by the way. So C1's reading is 2.87 centimeters. I'll just write that here, 2.87 centimeters. So we can say that obviously option B is incorrect. Now we have to decipher C2. I'm going to erase all of this here so that we have space. So let's get started on C2. So the basic piece of information that they gave us about C2 is 1, the thing that's underlined in black, which is common for both, and 2, the thing that's underlined in green, which is that 10 equal divisions of the Vernier scale correspond to 11 main scale divisions. So they told us that 10 VSD is equal to 11 MSD. This means that 1 VSD is equal to 11 over 10 MSD, which is equal to 1.1 millimeters. That's what we got here. Now in C2, we're going to approach this in a different way compared to C1 because the number of VSD coinciding is less than the number of MSD, which is reverse to what we're used to. So what I'm going to do is that I'm going to take this and draw in a bigger scale. Actually, before we do that, we'll just simplify it a little. So first we're going to find the Vernier 0, which is right here. And then we're going to find the corresponding main scale division, which is this. And that is 2.8, as before. Now let's draw this out a little. I'm going to take this and draw it in a bigger scale. This right here is 2.8 centimeters, and this is the Vernier 0. Now, let's find out which Vernier scale division coincides with one of the main scale divisions. And this, no. But this coincides, and this is the 7th Vernier scale division. So we know that the 7th Vernier scale division coincides with one of the main scale divisions. And let's check which main scale division that is. So that would be, this is 2.9, 3, 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6. So it coincides with 3.6. So what I'm going to do is that I'm going to draw these right here. Let's just say this is 2.9, 3, 3.1, and also don't really look at the accuracy of the lines here. I'm just drawing it for, visual reasons. 1, 2, 3. I'm just checking how many lines we have to draw. 1, 2, 3, 4, 5, 6, 7, 8 lines. So 1, 2, 3, 4, 5, 6, 7, 8. So this right here is 3.6, and those are 8 lines right there. Now we have to draw the others, which is 7 onward, for the Vernier scale, basically. This is, okay, that's a little to the side, but that's 7, 6, 5, 4, 3, 1 second. 2.9, 3, 1, 2, 3, 4, 5, 6. Oh, that makes sense. 7 is here. 6, 5, 4, 3, 2, 1. Okay. Sorry, I got confused there for a second. So that's a sign. You gotta be careful when you're drawing the lines. So this is 7, okay? So here we've got this portion of the diagram, this right here, drawn out to that. So our reading here, the reading that we observe on C2 is 2.8. Let me use a different color. It is 2.8 plus the distance between these two, this yellow portion shaded right here, It's the distance between the division of 2.8 on the main scale and the vernier 0, the distance between those two, plus the main scale reading, which is 2.8. So our main objective here now is to find this distance right here, and I'm going to name that distance as x. Let me use black. Okay, so this distance right here is what we're trying to find, and that distance is x. So that's what we're going to find. Now, if we think about it, this part is pretty simple, because x right here, or the distance between these, the vernier 0 and this, is what we need to find. So what I'm going to do first is that I'm going to find out the distance next to x. Oh my god, this coloring is different. This distance right here is what I'm going to find first. That distance, this one right there, this is equal to 7 vernier scale divisions. And this one right here is also 1, 2, 3, 4, 5, 6, 7. This is also 7 main scale divisions. So if this complete thing is 7 vernier scale divisions, and this complete thing is 7 main scale divisions, then this distance that we're talking about right here is actually 7 VSD minus 7 MSD. So this would be equal to, well, we got 1 VSD as 1.1 millimeters, so if I convert this into centimeters, this would be 0.11 centimeter. And the 7 VSD would be 0.77 millimeters minus 7 MSD, which is 0.7 millimeters. So this is equal to 0.07 millimeters right here. That would be this distance right here that I've marked in blue. Now if we want to find x, let's expand this portion. This portion right here, I'm going to expand. Let's draw it out over here. This is 2.8. And this is that line. And let's say that the 0 is here. I'm just exaggerating the distance. This is a vernier 0. And this is the next division, which is 2.9. Now the distance that we just found out, which is 0.07, that is this distance. This one right here. That is 0.07 centimeters. Now the x that we're trying to find is this distance right here. This is x. So what would x be? X would be the complete MSD minus 0.07, right? So x is equal to 0.1 minus 0.07, which is equal to 0.03. That is x. And now we know, as I've mentioned before, the final reading of C2 is equal to 2.8 plus this x. So that would be 2.8 plus 0.03, which is equal to 2.83 centimeters. So our final answer would be option D, right here, which is this.